Good afternoon, folks. My name is Mr. Gopal, and today I will be your living environment teacher. And in these COVID times, we are looking at a very important subject today, and that is homeostasis, and self-regulation, and immunity. Now that we are in the midst of a pandemic, it's more important than ever to understand how our body has an immune system that supports our behavior and a homeostasis feedback loop that allows us to persevere through difficult conditions. So what I'm doing today is I'm going to go over our Unit 4, Day 4 lesson on thermoregulation and its connection to human health. As I said before, we're in the midst of a pandemic with COVID, and so it's vital that students understand how homeostasis and immunity come together to keep us safe. And if you look through this lesson, we're looking specifically at thermoregulation. And not only do I want to help you understand what that is, but I want to help you become better readers. It's said often that the living environment exam, the Regents Living Environment exam that is not only a science test, but maybe even primarily a reading test. The better you are at reading, the more you'll be able to support yourself in situations where it's challenging to understand exactly what the question's asking or what difficult, dense vocabulary words actually mean. With that in mind, I've made this support document for you, and I want to talk about thermoregulation by using this diagram. So we know that the body often has falls and rising moments in its temperature. And we can see from this flow chart what happens if the body temperature falls. For example, blood vessels will constrict. That means they will tighten up together so we can conserve more heat. Sweat glands don't secrete fluid because we know if we sweat, that's ultimately going to lower our temperature by covering us in sweat. And shivering will generate heat to warm the body. On the other hand, if the body temperature rises up, blood vessels will dilate or grow larger, and that means not as much heat will be maintained. In fact, heat will be lost to the environment surrounding us. Sweat glands will secrete fluid, and by giving off that fluid, we're able to lower our temperature as the fluid evaporates. Okay, and so we call these loops negative feedback loops because we're responding to something in the environment that's taking our body in a certain direction, and we don't like it. So we have a negative feedback loop in order to bring us back to a state of balance. And that's what we mean when we say homeostasis. It's the maintenance of equilibrium or a state of balance in the body. And so unbeknownst to us, our body is reacting to all sorts of environmental triggers and adjusting us to maintain optimum health. And so as I say here in the diagram above, homeostasis illustrates how the human body deals with changes to its overall temperature. If our bodies don't smartly react to changes in temperature, we could freeze to death or even die of fever or heat stroke. Now I want to talk about reading well. The living environment exam, as I said before, is chock full of difficult vocabulary words. They're highly scientific, they're highly syllabic, meaning they have a bunch of syllables strung together, and they usually look a little bit intimidating. So here I am to break them down. So thermoregulation. First of all, it's the act of regulating or controlling our body temperature through changes in our body systems. So I like to think of that word regulating as a fancy way of saying controlling or monitoring, I guess you could say. And as I say down here in the definitions for hypo and hyperthermia, therm refers to heat. Okay, so whenever I'm talking about therm, whether it's thermal energy, which is heat energy, or hypothermia or hyperthermia, I'm talking about a subject that's related to heat somehow. The prefix hypo, which I underline in this definition, means below or under. So if we put these together, we mean below temperature. Hypothermia is a state where our body temperature is dangerously low. On the other hand, you might think of hyper as overly active, and that's pretty accurate because hyper means above or over. Again, therm refers to heat, and if we put them together, we mean above temperature. And so hyperthermia means a state where our body temperature is dangerously high. As we saw before, each one of these provokes a negative feedback loop from the body. Our body notices that our temperature is too high or too low, and adjusts accordingly in order to bring it back to a state of homeostasis or balance and stability. Now, I've put together a few questions based on this article and then the Regents questions that follow it. This article is linked in this lesson, and it's about the Texas Heart Institute and how they perform heart surgery. Now, the part that's crucial for our understanding are cooling techniques that allow surgeons to perform heart surgery. So, as we can see here, cooling techniques let surgeons stop the heart for long periods without damaging heart tissue. Now, that might seem kind of crazy to us. The idea of stopping the heart in order to save somebody seems counterintuitive. If I stop my heart, I feel like maybe I'm going to die. However, because of homeostasis, we can cool the heart, slow it down, even stop it, and then inject a solution to stop it completely. And we can maintain that state for 2, even 4 hours while we perform surgery. The important part for homeostasis is this sentence here: cool temperatures avoid damage to the heart tissue by reducing the heart's need for oxygen. So we talked about how temperature regulation is affected by the body, and different temperatures for the heart will require different amounts of oxygen. We can maintain someone on life support through an external machine while doctors do the important work of operating on that person's heart. So I have here for you a few questions for you to answer in your own words. Why do heart surgeons need to stop the heart in order to perform surgery? How does cooling the heart to very low temperatures allow surgeons to safely perform surgery on it? And how does homeostasis finally help heart surgery patients stay alive, even though their hearts are temporarily stopped? By looking at this situation, we're encountering a very real situation where homeostasis is used in order to prolong people's lives and make them healthy. Now, a very key part of culminating this lesson is going over how to approach these Regents questions. And I wanted to talk to you directly about that. One of the tough things about Regents questions is you might understand the answer in your own language, but you need to understand it in terms of dense vocabulary that appears on the exam. So we see the following situation diagram from left to right. A person exercises and body temperature increases. Small blood vessels near the surface of the skin increase in diameter, and then ultimately the body temperature decreases. And so we know that we're talking about homeostasis here. Why? Because a person goes through something that changes their body temperature in a certain direction, the body reacts in a certain way, and then the temperature is brought back down or it decreases. So we know that the best answer for this is number 2. If we're looking forward, other things that I want to point out is that cellular respiration is different from respiration. If we're talking about respiration, we're usually talking about the act of breathing itself. I like to think of cellular respiration as a cell's chance to breathe. If we look down here, it's the process of energy creation. They take in oxygen that we're breathing in, they release carbon dioxide, and we combine the oxygen with energy from food sources in order to maintain each and every one of our millions of cells. As you can see down here, when it comes to answering these Regents questions, I've got keywords that specifically tie to homeostasis. Those words are maintaining, increasing, and decreasing because those words show up in the Regents questions that we're doing. Okay, this is an incorrect definition that I need to correct. Respiration by itself means the act of breathing. Okay, so once again, when a human being respirates, that human being is breathing. When a cell undergoes cellular respiration, that is the process of energy creation, which is supported by the act of breathing. Finally, if you look at this, I'm going to direct you to the Regents problem annotation process that I like to engage my own students in. So we see a definition over multiple sentences, and then we see that we need to choose a reason why maintaining an appropriate temperature is beneficial to an organism. Now, we know that maintaining is one of our keywords for homeostasis. So we go down here, you want to underline the question, which is in a statement in the final of those 3 sentences. Box any important science vocabulary and relate it back to the sheet. Okay, so we have these definitions up here, along with the diagram, as well as these support vocabulary definitions down here. Finally, we eliminate information that seems irrelevant to the question and solve. As you can see, now that we have vocabulary together, this particular question is a lot easier to answer. We can eliminate bodily processes that seem irrelevant to maintaining appropriate temperature, even though they are processes that the body undergoes. In closing, I would just like to say again that the living environment exam is a reading test in many ways. You can forget some of the science, but if you read very carefully, you will do very, very well on this exam. So things to remember that I did, but I didn't signal. You want to take words and break them down wherever possible into their constituent prefixes and roots. This ensures that you can take intimidating vocabulary and make it much more transparent and easy to understand. Good luck, and I hope to talk to you soon.